Hi, in this video we're going to talk about converting in bases other than base 5. You should make sure that you've watched the base 5 video first so you get the hang of the general idea of it. Last video we talked about converting in base 5 from a base 5 number into a base 10 number here in this example, or from a base 10 number into a base 5 number here. Now we're going to talk about what if we had base 7. It's the same kind of game in terms of BizBuzz, except that every time we get to a 7, we say biz. It's also the same kind of idea with our flats, rods, and units. But now we're going to play base 7. So here we go. So we would need base 7 flats, rods, and units, and a table with powers of 7. So here's the base 7 flat, here's the base 7 rod, and here's the base 7 unit, and here's our table. Here, notice that our base 7 flat is 7 by 7, or 7 squared, which is 49. Our base 7 rod is just 7 to the first power, and our base 7 unit is 7 to the 0 power, which is 1. The only thing I haven't pictured here is the cube. So let's look at 2, 3, 4 with a little 7. How would we start converting this number into base 10? Now, what I want you to think about for a second is, are you in base 10 right now? Are you in base 7 right now? Which is this number in, base 7 or base 10? That's going to help you a lot to start. If you're already in base 7, the number itself, the 2, 3, 4, tells you how many of each type of base 7 block you have. So we are in base 7 because it has a little subscript of 7. So we're going to place that directly into the base 7 table, and we're going to make 2 base 7 flats, 3 base 7 rods, and 4 units. Then we multiply each place value by the value on the table, each number by the place value in the table. So we have 2 49 blocks, we have 3 7 blocks, or 3 times 7, and we have 4 units. We just multiply and add. And the answer is 123, which is our base 10 number. Next, let's try converting 207 into base 7. How would you start? Are you in base 7 already, or do you need to convert into base 7? So is this number here in base 7? No, it's not. We can tell because there's no little tiny subscript 7 on the number. So what we are going to need to do is make our table still, but we can't place the 2, 0, and the 7 into the table. Instead, we're looking at what goes into the table to equal 207. So we're going to start with our cubes, 343, and that's too large. So then we go to the 49s place and see how many 49s would fit into 207. If you divide 207 divided by 49, you get 4. And 49 times 4 is 196. Now wait a second, look at this for a second. I took the decimal remainder off there. If you on your calculator do 207 divided by 49, you don't get 4. You get 4 point something, but that means you need 4 flats. So we do 4 flats right here, and that's 4 times 49. We've taken care of 196 so far, but we need to get to 207. So 207 minus 196 is 11. So now we have these two place values to take care of 11. So how many 7s and how many 1s do you need to make 11? Let's see. I've got 7. That's 1 7. 8, 9, 10, 11. 4 left over. So we need 1 7 and 4 1s. And the answer is 414 with a little 7. 207 is our base 10 number. 414 is our base 7 number. Important note. Note that when we converted from base 7 to base 10, we used a base 7 table with the powers of 7. And when we converted from base 10 to base 7, we also used a base 7 table with powers of 7. We never used a base 10 table. We always used the powers of the strange or weird or odd base that we're converting to or converting from. So that should help you with our next example. Converting in base 12. So let's convert 273 with a little 12 on it into base 10. Step 1. Make a place value table for the powers of the strange base. In this case, base 12. Never for base 10. So here are the powers of 12. Now, the number 273 is in base 12, so it goes right in the table. And then we just multiply each digit by its place value and add. So we get 375 as our answer. That should say example 10 there. Whoops! Example 10, converting 394 into base 12. So here goes. We're going to, again, make a place value table for the powers of the different base, in this case, base 12. So here we go, base 12 table again. But this time, you cannot put the number 394 into that table because it's not a base 12 number. So we put it outside the table, and we try to figure out how many 144s do we have, then how many 12s, then how many 1s. To figure it out, divide the largest place value you can. So in this case, 144 is the largest that'll fit into 394. So we divide and get 2.736. So that means we just put the 2 there. 2 times 144. So far we have 288, right? 2 times 144. Yep. And now we subtract. So we have 106 left. So if we have 106 left after subtracting, that means that's 106 that we have to take care of in the 12s and the 1s place. 106 divided by 12 is 8, or 8.8333, right? So 8 goes in the next place. And then that gives us 96 more. 106 minus 96 is 10. And strangely enough, the 10 is what goes in the 1s place. That's because in base 12, we can have 10 in a base 12 column. In fact, we can have up to the number 11 in a base 12 place value column. Just like in Mayan. In Mayan, you can have up to 19, right? Because Mayan, the place value is 20. In our place value system, ours is base 10, right? So we can have up to 9. We have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when you guys invented your number systems, if you were place value, I said you need values for every number up to 1 less than your base. So, but the trouble is we can't write 2, 8, 10 because that would use up 4 place values. So instead we're going to use T for 10 and E for 11. Or any letter you like, as long as you tell me what it stands for. And so then we write 28T for our answer. And if you look in the textbook, you'll see a little bit more about why you can't write 2, 8, 10, and what happens when you use up 4 place values instead of 3 place values. So please read the text for the next type of converting, which is base 2. I mean, obviously I want you to be able to convert to any number, but base 2 is sort of special because in base 2 you can only have a 1 and a 0. That's why your computer on-off switch, if you look at this picture, it's a computer on-off switch is 1 and a 0, on or off, right? Only two options, one or the other. And in base 10, we can write numbers from 0 to 9, but in base 2, in base 5, 0 to 4, But in base 2, only 0 and 1, right? Right up to 1 less than your base. And that's the language deep down inside your computer. It's the electrical impulses, on, off, right? And so right there, that was just turning the switch on. If you turn the switch on, and then on again, and then off, and then on again, that gives you a binary or base 2 number. So have a read about it in your textbook, and please come to the discussion with any questions you have. We're happy to all talk about it as you practice. See you in the discussion.